Okay, so this is chapter 0.2, fractions. This is from the book Beginning and Intermediate Algebra, an open source textbook. That's what I'm using, and we will go right away to page 12. There it is. Okie dokie. So, let's just get this show on the road. So the objective is to reduce, add, subtract, multiply, divide with fractions. Working with fractions is very important. And then they do like a little worldview. Fractions began in the Middle Kingdom of Egypt. So fractions began in the Middle East, 2000 BC. That's like 4,000 years ago. So that's how old the stuff we're learning. Everything that we learned after was developed after this point, or at this point in history. So let's look at 36 over 84. Both the numerator and denominator are divisible by 4. So 36 divided by 4 equals 9. 84 divided by 4 equals 21. And you can see that right here. Now, a little trick. Anytime you have like two even numbers, you know they're divisible at least by 2. Both numerator and denominator are still divisible by 3. 9 divided by 3, 21 divided by 3, that's our solution. The previous exam could have been done in one step by dividing both the numerator and denominator by 12. We can also divide it by 2 twice, then divide it by 3. The order really isn't important. So the easiest operation with fractions is multiplication. We can multiply fractions by multiplying straight across, multiplying numerators together and denominators together. So yeah, it's pretty easy. When you have 6 over 7 multiplied by 3 over 5, it's 6 times 3. That's 18. 7 times 5, that's 35. That's our solution. Boom. Can this be reduced? No, not really. This can be divided by 2, 3, 6, 9. This is 7 and 5, so forget it. When multiplying, we can reduce fractions before we multiply. We can either reduce vertically with a single fraction or diagonally with several fractions, as long as we use one number from the numerator and one number from the denominator. So what are they saying here? When 25 times 32, or 24 times 55, reducing 25 and 55 and dividing by 5. Reduce 25 by dividing by 5. So they're saying you can reduce this guy and this guy by dividing by 5. They're saying reduce 32 and 24 by dividing by 8. And that's the result. That's pretty tough, actually. So let's... All right, so they're saying here 25, I did. 25 over 24 times 32 over 55 equals. Now, what this equation really is 25 times 32 over 24 times 55. So what they're saying here is that if any one of these terms can be reduced, you can reduce it. So we start with the top and we work our way down. So 1 times 25 equals 25, 5 times 5 equals 25. Here, 1 times 24 equals 24, 2 times 12, 3 times 8, 4 times 6. So there's 1. Is there a 1 here? Yes. But can't divide anything by 1, so that's useless. There's a 25. Is there a 25 here? No. Is there a 5 here? No. So these two cannot be divided. Can't reduce these two. Now what they're saying is, maybe you can reduce these two. And you can divide everything by 5 here. So let's rewrite this equation. 5 times 32 over 24 times 11. I don't know why that did that anyways. Okay. So now we have, it's the same thing. This and this, it's the same thing. So we're done with number 5. So we're done with this, right? And we're done with this. So let's take a look at 32, and if we can put it in what's left. So 32, what equals 32? 1 times 32, 2 times 16. Can you do 3? No. 4 times 8, 5, 6. No, that's about it. Now 11 is 1 times 11, right? 1, forget about it. 11, 32, no, we can't do anything. What about 24? Well, what gives 24? We have it right here. And we have an 8. See that 8? We have the 4, we have the 2, but the 8 is the one I want to look at. So if I divide these two by 8, or I should rather say here, by 8, we're going to be okay. So let's rewrite that guy right here. So 5 times 32 divided by 8 equals 4, right? 32 divided by 8 equals 4. Over 24 divided by 8 equals 3. 3 times, let's carry over that 11. So now I think we're pretty much reduced. So that equals 5 times 4 equals 20. 3 times 11 equals 33. Is that the answer? Yes, that's the solution. Okay. So, as always, if you don't understand, look at it over. I'm going to clear this guy right here. Clear. So back to the problems. Dividing fractions is very similar to multiplying with one extra step. Dividing the fractions requires us to first take the reciprocal of the second fraction. The reciprocal is just a fancy word for opposite of the second fraction and multiply. We do this. Once we do this, the multiplication problem solves just as the previous problem. So what they're saying is that when you do anything divided by anything in fractions, you have to take the thing that you're dividing by here and inverse it. So 21 over 16 divided by 28 over 6 becomes 21 over 16 multiplied by 6 over 18. You see how they flipped it here? They flipped it and then they put a multiplication sign. And then you just do your problem as you did before. So what they did was they divided these two by 7, and they divided these two by 2, and you got the solution 9 over 32. Do I do this? I guess I could do this. So, that always does this. It's a pain in the ass. Okay, this division problem. Let's go for it. Let's just go for it. Example 18. 21 over 16 divided by 28 over 6. Now, as always in math, when you don't understand everything in the lecture, listen to it again a couple of times, and I try to do the problems with the professor, or the tutor in this case, and we see what's going to happen. So the first thing we're going to do is we're going to rewrite the first term, right? That doesn't change. 21 over. But since we're dividing, what we do is we multiply. Remember, multiplication can either be a dot or a multiplication by the opposite. Or, as your teacher will probably say, the reciprocal. Equals. And now we're going to start reducing stuff. Now you can reduce stuff a whole bunch of ways. Here it seems a pretty good reduction right here, because this divides by 7 and this divides by 7. So we're going to get a 3 over 16 multiplied to 6 over 4. Okie dokie. Now these ones here can further reduce, right? You can divide this by 2 and divide this by 2. So equals 3 over 8 multiplied by 3 over 4. Equals. Can any more reducing? Well, you could reduce these two. These two are divided by 4, but there's no numerator. It has to be a numerator and a denominator, not just two denominators. You could divide these two by 3, but once again, it has to be one from this floor and one from this floor, not two from the same floor. Okay, so let's do the multiplication and see the answer that we get. 3 times 4 equals. So here I get a 9, and here I get a 32. What's the answer that they say? Am I tripping? Yeah, that's a good answer. Okay. Good show, good show, good show. So let's clear that. Moving along. Example 19. Find the lowest common denominator of 8 and 12. Test multiples of 12. What are they saying here? 8 and 12. What are they doing? Yes, we can divide 8 and 12. Am I tripping? To add and subtract fractions, we first have to find the least common denominator. There are several ways to find the lowest common denominator. One is to find the smallest multiple of the largest, and you can divide by the small. Okay. Find the lowest of 8 and 12. Oh, okay, I understand what they're saying. Yes, okay. So what they're saying is 8 and 12. I find that's a pretty confusing way to do it. All right, so what they're saying is that when you're adding fractions, let's do an example. 1 over 8 plus 1 over 12 equals. What they're saying here is that the denominators have to be the same. All right? They call that the lowest common denominator because you don't want to do it by a million, right? You want to do it as low as possible to work with the smallest numbers possible. So what they're saying is that what could you multiply this by, and what could you multiply this by so that these would be equal? So what they're saying here is that if I multiplied this by 2, I could get 24. 24. If I multiplied this by 3, I could get 24. So, don't forget, you got to multiply at the top, right? This only works, this multiplying of parts of fractions only works when you do the same thing to the numerator and the same thing to the denominator. All right. So, here we have 3 times 1 is 3. 3 times 8 is 24, plus 12 times 2 is 24. 1 times 2 is 2 over 24. So now when you're adding, what you're going to do is you're going to add the numerators, and you're going to keep the same denominator because you're adding fractions. 5 over 25. Oh, wait a minute. Wait a minute. Can you reduce this? Right? 5. Can you put 5 and 25? Yes, you can. So that would really be 5 divided by 5, 25 divided by 5. So that would be a 1, and 25 divided by 5 is a 5. So let's think about this. If I had a pie here, and I broke it up into, like, I don't know, 5 parts. Let's say these are 5 equal parts. So this is 1/5, this is 1/5, this is 1/5, this is 1/5, this is 1/5. All right? So what we have here is 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 equals. So now we said that when the denominator is the same, you can add numerators. And that would be 5 over 5. 1 plus 1 plus 1 plus 1 plus 1 equals 5 over 5. When you do 5 divided by 5 and 5 divided by 5, what you really get is 1 over 1, which is 1. And that makes sense because it's 1 pi. You're getting 1 pi out of that, right? So that's what's happening there. Okie dokie. Let's continue after next video.